What's going on YouTube? In this tutorial, I just want to talk about a couple different approaches that you can take to run a regression in Microsoft Excel, and watch till the end because one approach is a little more detailed, where another approach is a little bit more robust and will kind of update as your data changes. So to run a regression with some more detailed statistics stuff in Excel, first you want to highlight the data that you want to run the regression off of. So here we have a x and a y value. And to run this regression, we want to just hide the data, like so. Then we want to go to the Data tab. And then on the right, you're going to see Analyze and Data Analysis at the top. You're going to want to click on Data Analysis. One thing to note, if you don't see Data Analysis, you're going to have to go to File Options and then add it as an added. If you don't see it, once you get that, you'll have a Data Analysis option. Where here you can see different pieces of things that you can do to do analysis on your data. One of those things is a regression. And then click OK. And here you'll see an input page where you can put information where you'll be able to customize what you put into regression and kind of what you get out of it. So here you have a Y range and an X range, and also there's some options. So for example, you can have labels, which if you click this box, it assumes that the first two rows is labels for your data set. You can set a confidence level if you want. I just randomly put 95% as an example, but do what you feel is best for you. You can have a constant set of 0, and you can also select your output range. So the output range is just basically where is the regression going to be set. You can have it in a new worksheet. You can even have it in a new workbook, or you can have it in whatever range that you want in the same worksheet that you're working in. Whatever fits your needs. I'm going to have it in the same worksheet that I'm working in, from cells G1 to O31, but just because I can kind of compare it side by side. You have options for your residuals too, so you can have residuals included or not included. So if you check this box, residuals will be included. Standard residuals to be included if you check this box. Residual plots, line fit plots, normal probability plots too, if you check these for boxes, will be included. But uncheck and check to include or not include what you feel fits your what you're working on best. And click OK. Give it a second now. Here you can see. Here's a basic regression. So we're going to highlight this by doing Control Space, Shift right or a little bit, Alt H O I to just kind of fit this out and make it look a bit better. So you have your multiple R, your R squared, adjusted R squared, standard error, number of observations. So you have this ANOVA stuff. I'm not sure exactly what this stuff is. I'm not gonna lie, but it's there. Coefficient, standard error, t-stat, p-value, lower 95%, upper 95%, lower 95%, whatever fits your needs. Predict observations, predicted y value, predicted x value, standard residuals, and kind of the various plots that you said that you needed off to the side over here, and so you can get a better, clear picture of data that you're working with. And this is awesome because, as you can see, it is pretty detailed in the kind of the key piece of information that you need to do analysis of your data and to get a picture of what the distribution of your data set looks like. But one thing to note though is that this doesn't change with your data. So let's say I type in the changes to 19 to, I don't know, just a random large number. I press enter. This data doesn't change off to the side. So there's another approach they can take. Yes, it's not as detailed, but it's a little more robust because it will change as your data changes. So to kind of talk about this other approach, one thing you can do is you can make a graph and just put an equation and put a trend line on the graph and then have the equation shown on the graph. So to do this, just highlight the data and then you can press Control Tab, or you can just go to Insert, for example. You can go to Recommended Charts, and why not a scatter plot? Click OK. Okay, I'm going to Control X and then Control up arrow, just kind of bring the scatter plot to the top, and boom, here is our scatter plot with the lovely title chart Y. And this is great because now we have a little bit of a better visual of the data, in my opinion. But you can also click this plus right here, and where you can add different things to your chart, and here you can click a trend line. but you can have different options to adjust the trend line to meet your needs. So click on this right arrow. You can have a linear trend line, an exponential trend line, a linear forecast, 2-period moving average, which is totally crazy. More options. Clicking on more options, you can have the trend line name be whatever you want. So you can have it be automatic. You can customize the trend line name. You can have a forecast, which you don't necessarily get the initial like regression, whatever you need. But you can scroll to the bottom and then you can display the equation and you can display the R value on the chart. And this is great too because you can kind of quickly and easily see, will a exponential regression better fit my data? Will a linear regression better fit my data? Will logarithmic trend line better fit my data? Linear seems to be the better one, I guess, by the R squared value, but you can also click on this, go to the fill tab, and then change the color so you can see better, change it to black, make it a bit bigger so it changes to 2.5 points, and then change the compound type, not from dots. I don't like the dots in this because it's scatter plot, but to a line. And then going to here, clicking on the formulas, going to the home tab, clicking on the text color, and clicking on black. But this is great too because this will now change as your data changes. So if I type this 32 to 1000, as you can see, the data changes and the graph totally changes, and the R squared value drops from 0.6 to 0.05. But that's very helpful because if your data changes, then you can kind of more visually see that, and you won't have to rerun the regression, though it is less detailed. Another super kind of even more basic thing you can do is you can use the lin_s function, which just gives you a basic linear equation for your data. So equals lin_s. You can have your known y's. So you can have your known y's. So let's just say y's right here. Then your known x's right here. And then you can also select your constants and your stats, but those arguments are optional. I'm just going to close parentheses. And right here you get the slope, and here you get the intercept. And as you can see, this is just basically a super basic linear equation for your data, but like the graph, it changes as your data changes. That's it. I hope you found this to be helpful. If you did, like, subscribe, comment. Thank you for watching. Have a great day.